Hi, everybody. This video is going to be on section 2.7, marginal analysis in business and economics. And we have marginal cost, revenue, profit, a whole bunch of definitions. So let's just start right now. So looking here at these definitions, marginal cost, revenue, and profit. If X is the number of units of a product produced in some time interval, then the total cost is called C of X. It's the cost based on X. The marginal cost is the derivative C prime of X. The total revenue is R of X. The marginal revenue is R prime of X, the derivative. The total profit is P of X is R minus C. The marginal profit is P prime, or R, which is R prime minus C prime. So marginal cost or revenue or profit is the instantaneous rate of change of cost or revenue or profit relative to production at a given production level. Meaning by production level, I mean how many units, how many X number of units there are. Okay, well, that's the basic definition. So basically, whenever you see the word marginal in business, when we translate it into math, it means the derivative. So let's look at an example. A company manufactures fuel tanks for cars. The total weekly cost in dollars of producing X tanks is given by the equation C of X equals 10,000 plus 90X minus 0.05 X squared. And again, how they came up with this function, that's a whole other thing. And as I mentioned several times, coming up with these equations, coming up with these formulas for cost or revenue or whatever, sales or who knows what profit, that's a very good job. That's a very lucrative career, this sort of thing. It's, just saying. Anyway, so A, find the marginal cost function. That's going to be very similar. That's just going to be a straight derivative. So it's going to be 90 minus 0.1x. Where'd the 0.1 come from? Because 2 times 0.05 is 0.1. Find the marginal cost at a production level of 500 tanks per week. Well, that just means plug in. That just means go to C prime and plug in X equals 500. You plug in X equals 500, you get 90 minus 50, which comes out to 40. That's the marginal cost. And interpret the results. So at a production level of 500 tanks per week, the total production costs are increasing at a rate of $40 per tank. We expect the 501st tank to cost about $40. Good to know. And the C of 501 is equal to 10,000 plus 90 times 501 minus 0.05 times 501 squared, which is $42,539.95, but who's counting? And C of 500, well, that's going to be 10,000 plus 90 times 500 plus 0.05 times 500 squared, which is 42,500 even. And C of 501 minus C of 500 is $39.95, which we said before was about $40. And that, my friend, is the exact cost of producing the 501st item. Yay. Okay, theorem 1. If C of X is the total cost of producing X items, and the marginal cost function approximates the exact cost by producing the X plus first item, which in C prime of X is approximately C of X plus 1 minus C of X. And we're saying this about cost, but we could have said this exact same theorem, but substitute the word revenue for cost, or substitute the word profit for a cost. So in other words, this formula applies to all three of these things. Boing. Okay. Let's look at this. Let's do another example. Example 2. The total cost of producing X bicycles is given by the cost function C of X equals 10,000 plus 150X plus 0.2 X squared. Find the exact cost of producing the 121st bicycle. Oh, this is math 121, and we want to find the 121st bicycle. It's so fitting. Use marginal cost to approximate the cost of producing the 121st bicycle. So let's just take this one at a time. So the exact cost of producing, okay, so the cost of producing 121 bicycles is C of 121, which is 10,000 plus 150 times 121. We're just plugging 121 into this top formula. Plus minus 0.2 times 121 squared, that comes out to $221.80. And the cost of producing 120 bicycles is if you plug 120 into the formula, you get 25,120. Well, if 121 bikes cost you this much and 120 bikes cost you that much, the difference is at 121st a bike. So the difference is 101.80, $101.80, and that's the exact cost of the 121st bicycle. Now, using the theorem, we know that we're evaluating when x equals 120, I'm sorry, and C prime of x is 150 minus 0.04x. That I get just from taking the derivative, and just taking the derivative of this formula they gave us. So C prime of 120 is 150 minus 0.4 times 120, which is equal to $102. And that's pretty close to $101.80. So it's not a bad approximation at all. So there you go. Okay, let's look at another example. Production strategy. A company's market research department recommends the manufacture and marketing of a new headphone. After suitable test marketing, the research department presents the following price-demand equation. And that is X equals 10,000 minus 1,000 P. X is demand at price P. And in the price-demand equation that we had, the demand X is given as a function of price P. By solving for P, which is just simple algebra, we get P equals 10 minus 0.001x, where X is the number of headphones that retailers are likely to buy at P dollars per set. So the financial department provides the cost function. C of X is equal to 7,000 plus 2x. And figuring out the cost function really does not have anything to do with the price or demand or any of that stuff. It's just how much it costs to produce this. Now I don't know. Again, I'm not in business, but I always thought that cost involves the manufacturing. I don't know if they can count advertising or who knows what they count in this when they make a cost function. But that's business. I don't really know business. I just know math. But whatever it is, we'll just throw it into the equation. So where 7,000 is the estimate of fixed costs, tooling, overhead, so forth, and $2 is the estimate of variable costs per headphone, and materials, labor, marketing, transportation, storage. I knew somebody who was in the hat business, but he got out of it because there's too much overhead. You get too much overhead. Okay. Find the domain of the function defined by the price demand equation. Domain, that's interesting. And find it. Well, let's just take this one at a time. Since the price and the demand have to be non-negative, so P has to be greater than 0, and of course X also has to be, greater than 0. But X has to be less than 10,000. Obviously, X has to be greater than 0. So X is between 0 and 10,000. And you can get that from this equation. I say inequality. Find and interpret the marginal cost function C prime of X. Well, that you just take the cost function, take the derivative. Basically, the 7,000 disappears. I'm just left with the 2. So the cost function, so C prime is 2. And so since this is a constant, it costs an additional $2 to produce one more headphone at any production level. Find the revenue function as a function of X and find its domain. But there's a lot of parts to this problem. So the revenue is the amount of money R received by the company for manufacturing and selling X headphones at P dollars per set, and it's given by R is the number of headphones sold times the price per headphone, which is XP. And in general, the revenue can be expressed as a function of P using equation 1 and I get R of X equals XP, which is X times 10 minus 0.001X, because we figured out that P is equal to 10 minus 0.00X. We did that before by solving for P. And if I multiply this all out, I get 10X minus 0.001X squared. And since the second equation is defined only for X between 0 and 10,000, then the revenue function also has to be only defined for X between 0 and 10,000. That's just the way it works. Alrighty, and that's been loads of fun. And now we're gonna go now we're gonna look at marginal average cost, revenue, and profit. So marginal average cost, by the way, everything I'm showing you here, this textbook I'm showing you, this is in your Math Excel. All you do is you click on Math Excel where it says textbook, and you can get all this stuff. So all this stuff you can look up on your own, although you see it here on this video. Okay, marginal average cost, revenue, and profit. So if X is the number of units of a product produced in some time interval, then the cost per unit and the average unit. So the cost per unit is as follows. The average unit is going to be C bar of X, which is C of X divided by X. Just when you take an average, divide by the number of things, you know. And the marginal average cost is going to be C bar prime, which is the derivative of C bar. And of course, the derivative of C bar, that's going to be very interesting because I'm dividing by X. Well, we'll see. It won't be that hard. And the revenue, the average for revenue per unit, the average revenue is R bar, which is R of X divided by X. And the marginal is the derivative of that. And the average profit is P of X divided by X. And the marginal average profit is going to be the derivative of the average profit. So now, of course, Moses was not just an average prophet, he was a superior prophet. You get to see what I did there. I made it a little fun. Anyway, cost analysis. A small machine shop manufactures drill bits used in the petroleum industry. The manager estimates that the total daily cost in dollars of producing X bits is C of X equals 1,000 plus 25X minus 0.1 X squared. So find C bar of X and C bar prime of X. Find so C bar is equal to C of X divided by X, which is going to be this formula right here, divided by X. So it's 1,000 over X plus 25 minus 0.1X. And this derivative can easily be found using the power rule. And C prime is going to be the derivative of C bar, which is going to be negative 1,000 over X squared minus 0.1. And again, you can differentiate this using the power rule. C bar of 10, now just plug 10 into this function, into this formula, it's this equation that we got. And C bar of 10, you just plug it into the first equation, you get 124. C bar prime is negative 10, 10. So the production level of 10 bits per day, the average cost of producing a bit is $124. This cost is decreasing a rate of 10, 10 per bit. If production is increased by 1 bit, then the average cost per bit will decrease by approximately 10, 10. So the average cost per bit at a production level of 11 bits per day is approximately 124 minus 10, 10, which is $113.90. And that, my friend, is the story. And that's the end of this section. So see you guys next time. The next video is going to actually be already in chapter 3. Yay for us. See you guys. Have fun. Bye.